Hello and welcome to the Maths department of Queen Elizabeth Sixth Form College. During the next 10 minutes, I'm going to give you a mini lesson on one of the topics that we cover in the first year of A-level further maths. And that topic is called matrices. So before we go any further, what is a matrix? Well, the dictionary definition is that it's a group of numbers or other symbols which can be arranged in a rectangle, which can then be used as a single entity, used together as a single unit to solve mathematical problems. Mathematicians had been used to grouping numbers together or algebraic symbols together, but it wasn't until a mathematical revolution took place in the mid-1800s when groups of numbers started to be treated as a single entity. One of the uses of matrices is in solving systems of equations. Now, at GCSE, you solve a pair of simultaneous equations. You have two equations and two unknowns, but we can extend that. We can have three equations, three unknowns, four equations, four unknowns. But hopefully you'll realise that as you increase the number of equations and number of unknowns, it's going to become quite time consuming to solve these equations simultaneously. And that's where matrices come in and can help us. One of the things that you will do in A-level further maths is to solve three equations with three unknowns. And one of the outcomes of that would be to find the point of intersection of three planes. So here we have three planes, and in this particular case, they intersect at one particular point with the coordinates x, y, z. Another application of matrices that we will look at is in using them to describe transformations in 2 dimensions and 3 dimensions. Now you'll have already come across rotations and reflections and enlargements at GCSE, but at A-level here we will use matrices. Out in the real world, computer graphics artists make great use of matrices when they're controlling the motion of characters in both video games and then also in CGI films. And if you study computing either at A-level or later at university, it's very likely that you'll make big use of matrices at some point. So what does a matrix look like? Well, here we have a 2 by 2 matrix. That means it has 2 rows of numbers or letters and 2 columns, and it's given like this. Notice we've got big brackets either side. The numbers are lined up both in the rows and columns, but we don't use commas or full stops to separate the numbers. A 2 by 3 matrix has 2 rows and 3 columns and looks something like this. And then we have a 4 by 3 matrix where we have 4 rows and 3 columns, something like that. First, we're going to look at adding and subtracting matrices. It's really important to note that you can only add and subtract matrices which are of the same order. That means each matrix has to have the same number of rows and columns as the matrix that you're going to add it to or subtract it from. So for example, here we have two 2 by 2 matrices. They've both got 2 rows and 2 columns, so we're fine. What we're going to do is each entry in the matrix is called an element, and we're going to look at corresponding elements. So here we have the top leftmost element, and we're going to add that to the top leftmost element of the second matrix. We will then do the same with this element, will be added to that, this to that one, and so on. So what we get is we get 2 plus 3, we get -1 plus 4, 5 plus -7, and then the last 7 plus 6. And that leads to the resulting matrix 5, 3, -2, 13. Here we have a second example. This time we've got two 2 by 3 matrices. We've got 2 rows and 3 columns. So just as before, if we're going to look at the top leftmost entry, so if we've got A in the first matrix, we then subtract 1, that leads to A -1 in the resultant matrix. If we then jump to this last entry here, we've got F -6, F -6 in the resulting matrix there. We can't carry out the following operation, however, because the matrices are not of the same order. So here we have got a 2 by 3 matrix and we're trying to subtract a 2 by 2 matrix. We just can't do it. There are a number of special types of matrices. A square matrix, which you've already seen, has the same number of rows as columns. So for example, a 2 by 2 matrix or a 3 by 3 matrix. The zero matrix, sometimes called the null matrix, is one in which all of the elements are zero. And then we have the identity matrix. This is a square matrix in which all of the elements on the leading diagonal are 1 and all the remaining elements are 0. So here is a 3 by 3 identity matrix. If you multiply another matrix by an identity matrix, then the matrix will remain the same. We can multiply a matrix by a scalar. So by scalar, I just mean a single number. So for example, if we have a matrix A, which is a 2 by 2 matrix in this case, and I want to work out 2A, so 2 times the matrix A, then I just multiply every single element in the matrix by 2. Moving on to multiplying matrices, which is more complicated. Here we've got two 2 by 2 matrices again. I'm going to work with the top row of the first matrix and the first column of the second matrix, and that is going to give me the top leftmost entry in my resultant matrix. And what I'm going to do is I'm going to do 2 times 3 plus minus 1 times minus 7. So I've done 2 times 3 plus minus 1 times minus 7. I will then move on to look at the top row with the second column. So I will look at top row with the second column. So I will have 2 times 4 plus minus 1 times 6. I then move down to the second row and the first column. That's 5 times 3 plus 7 times minus 7. And then finally, I've got the second row with the second column, 5 times 4 plus 7 times 6. That then leads to the resultant matrix, 13, 2 minus 34, 62. So just take a minute to look at the calculations that have taken place. If you think about multiplication that you've been used to doing, so if you multiply 2 times 3, for example, you get 6. If you do 3 times 2, you get 6. You can do the multiplication either way round. However, that's not the case with matrices. It's really important to look at the order of the multiplication. So in general, if you've got two matrices, A and B, if you work out A times B, then usually it will not be the same as B times A. There are exceptions. For example, when you multiply a matrix by the identity matrix, then you can do it either way around. But in general, AB is not equal to BA. And we say that matrix multiplication is not commutative. We can only multiply matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. So if we look here, we have got 3 columns in the first matrix and we've got 3 rows in the second matrix, so we can carry out that multiplication. If we look at the second example, however, here we have got 3 columns in the first matrix, but we've only got 2 rows in the second matrix. So therefore, we cannot carry out that multiplication. I've just given you a very brief taster of matrices. So as I mentioned right at the start, it's one of the topics we cover in the first year of further maths. We'll then go on to look at how matrices are used in transformations and also solving equations simultaneously. Remember that if you require any further information, then one port of call might be the subject pages of the bridging section of the QE website, where you'll be able to access other mini lessons.